Welcome to Speakeasy JS, the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this morning. So you're joining us at our new time of 10 a.m. Pacific time, and thank you for being here. So mad science is all about building things that make people say, I didn't know that was possible. And today, we're joined by Antonio Lain to talk about Caf.js, co-design cloud assistance with your web app and IoT devices. Which sounds like a lot of things. So I'm excited to hear about it, and good to have you here.
Thanks for having me.
Yeah, of course. Oh, go ahead.
So today I'm going to talk about Caf.js. Caf.js is three things. It's a framework that is open source to create cloud assistants. It's also a custom platform for random. And then by combining these two things, we have created the Caf.js cloud that allows you to host and also to monetize your web apps with cloud assistants. So why do we need a custom platform? A typical cloud assistant every second is going to wake up, is going to compute for about a millisecond, and is going to create a checkpoint that is typically less than 500 bytes of compressed state. And then it's just going to go back to sleep. And we want that checkpoint to be very fast because we don't assume our request is fully done until we have a stable checkpoint. So if you wanted to host that...
Antonio, could I just interrupt for 1 second? What's a cloud assistant? Could you explain what a cloud assistant is?
I'm going to go there. It's just basically an actor that we run on behalf of a device or a web app instance. But I'll be getting there.
Okay.
So the idea here is that the cost per year, if you were to use a standard platform, like for example, serverless platform like Cloud Run, or a database like that has fast writes like Cloud Firestore, would be something in the order of $144 per year. So that is too expensive, right? So there are very, very few things that could afford to have one of these entities running on behalf of your device for a year for $144. So instead, with the Caf.js cloud, that costs about 85 cents. And the important thing is not the actual number that I'm giving you. Their plans are more expensive or cheaper. But the important thing is that once that you have something that costs that little, pretty much anything in the world can have one cloud assistant running. And in fact, we think we can have 1 billion of these cloud assistants with a few thousand servers. So what is the magic? I mean, how do we get these 2 orders of magnitude of cost difference? So the idea is that we have created a domain-specific pass, and that this is a platform that the only thing it can run is our cloud assistants. But then it can assume many, many things also. So, for example, it can assume certain ratios of compute, memory, and communication. It can assume some interaction patterns. It can assume some support services. And once you make all these assumptions, you ended up with a problem that is way much simpler than the one you started with. And now you can co-design the framework and the platform together, and that's what gives you the efficiency. So in this talk, I want to do a few things. I want to first convince you that cloud assistants are not only cheap, but actually they are useful. They can do really useful stuff to your apps. And then I'm going to show you an example of how to code a cloud assistant and compare with a standard framework like Express. And then I will talk a little bit about the Caf.js cloud and what is our philosophy of creating a cloud. And then if we have time, we will have a live demo. And if we don't have time, that's fine, because the demo is in YouTube, so you can watch it there. So going back to your question, Feroz, a cloud assistant provides 4 important features to your app. The first thing that it does is it can provide permanent presence for devices and also for application instances. The second thing it can do is it can do autonomous compute. So basically allows you to launch long-term activities in the cloud that could last years. And the third thing it can do is it can do orchestration of external API calls to other services, for example. And the last thing, and actually my favorite, is that it can help you to do collaborative multi-tenancy. It can help you to create apps in which users collaborate in a safe and very efficient manner. So let me first talk about permanent presence. What this means is that you want to guarantee safe interactions with devices and app instances at any time and from anywhere. But when I mean anytime, I also mean when the device is offline or is off. And that might sound strange. When I talk about anywhere, I also mean when the device is behind a firewall and therefore there's no other way to contact it. And you are only having a internet connectivity from outside. And there are two important use cases for having that functionality. One is to be able to take any Bluetooth device that is around you and be able to share it across the internet. And do that with just your mobile phone. And in the case of Android, with just the Chrome browser, no native app. And the other thing that we are doing is to basically take a real device, a physical device, and embed them into a virtual world, mostly using WebXR technology. So how does it work internally? Well, we have a technology that we call reverse service worker that plays a kind of a dual role to a service worker in a progressive web app. And the idea of a reverse service worker is that it ensures that when the device is offline or the application is offline, the rest of the world can actually make progress. And even if the device is offline or is difficult to reach. The second technology that we introduce is something we call three-way isomorphic. So with a three-way isomorphic framework like Caf.js, it's very easy to create bridging code for your device that it can run anywhere. So there is a demo of sharing Bluetooth devices in YouTube. That's the one I want to show you, so I'm not going to spill the beans. And there's another demo in YouTube that shows you how to get a Bluetooth bulb, in this case a Philips Hue, integrated in WebXR, in AR and VR. Let me talk about autonomous compute. So what we want to do here is launch long-term activities in the cloud and then be able to interact with them with a request-response model or just get a stream of events from them. And our important use case is what we call cloud-based multitasking. With cloud-based multitasking, what you can do is you can launch a background task in the cloud and then make it look like as if it were running locally in your phone. And the trick to fool the users into believing that something is running locally in your phone is to be able to context switch in a very smooth and quick manner and always showing progress between all these activities. And the way we actually do that is with a technology that we call proactive server-side rendering. So with proactive server-side rendering, we don't wait for a request to arrive to the server to render a page. Whenever the cloud assistant detects that there is a change in the internal state of the cloud assistant, it will re-render the page and push it to a cache that hopefully is closer to where you live. And then the client will just very quickly do a lookup and then continue with standard SSR hydration after that. And we think this technology is going to be great for 5G networks because of the low latency. There's a demo of proactive server-side rendering in YouTube, and I encourage you to have a look at that too. Reliable service orchestration. So what we want to do here is, when you have a task that involves a sequence of asynchronous steps, each of them potentially involving some external APIs of other services that you want to call, we want to ensure that if there is a failure, then we can actually restart the sequence safely and ensure that we are not going to mess things up by calling services more than once. And the other thing that we want to make sure is that instead of having to provide all these raw API credentials directly exposed to the browser, we want to create a weaker credential that summarizes the task and make it very short-lived, so that when we pass that credential to the browser, it's much less likely that a compromise will completely mess up things. And we think this technology is going to be a perfect fit for Jamstack, because in Jamstack, you don't have a traditional backend anymore. You rely on APIs for everything. And then the idea of having to do that orchestration in the browser is kind of crazy and very, very dangerous. And the technology is based on transactional actors and transactional plugins that I'm going to describe you when I show you a little bit of code in a moment. So there's a demo of a bulletproof PayPal checkout in YouTube that I actually encourage you to have a look too. And last but not least is the ability of creating collaborative multi-tenancy in your apps. So the idea of collaborative multi-tenancy is that you can extend multi-tenancy to bootstrap trust between strangers and help them to communicate. And the idea is that you bootstrap trust by using an internal abstraction that we have, that we call the trusted bus, that mediates interactions between all these cloud assistants and helps you to enforce some access control policy that you define. And we help people to communicate because we have built some high-level communication abstractions on top of that bus that help you to do publish subscribe or share data very efficiently. But it is a bit more fun when the interactions involve devices. And we have created something that we call the time bundles. And what time bundles do is allow you to trigger actions based on UTC time. And when you trigger actions based on UTC time, we can actually synchronize actions of hundreds of thousands of devices across the world. And if you give me a couple of seconds to propagate these bundles, these actions will execute within 100 milliseconds of each other in most cases. So you can really make a party with that. And there is a demo also of these time bundles using a Twitter-like interface. And unfortunately, it's not 100,000, it's only 2. But we can use induction to generalize. And okay, let me just show you some code and show you how to create a cloud assistant. The way you define a cloud assistant is you define a mixing of methods. And the idea is that methods can be either internal, when they have this funny prefix that have --ca-, or methods can be, all the others can be externally called using the client library, as I'm going to show you in a moment. All these methods are always asynchronous methods, and they always return a tuple array in which the first element of the tuple is an optional error, and the second one is actually the value that you want to return. Even though this might look like a little bit like a standard method in Express, the technology behind it is completely different. We are basically using an actor model, and an actor model provides an internal state for the actor that can only be modified by the actor itself. And this is all under the variable this.state. And it also provides a queue. And that queue per actor serializes actions. So what it's doing here is that even though increment has multiple asynchronous steps, as you can see, the queue is going to guarantee that we don't process the next request until all the asynchronous steps of the previous request are fully done. And in the case of Caf.js, we go beyond that, and we make serialization a global property. So you can have thousands of Node.js processes running your application, but we always guarantee that there's at most one instance of your cloud assistant running anywhere in the data center. And that instance is also going to serialize your requests. So what that means is that there's no more races anymore. So for example, in this case, when you call it increment, you might expect that increment will return a different value every time you call it. But if you were to implement this with Express, it wouldn't work at all, because the problem there is that if there is a call waiting in the timeout and another one comes in, when the first one leaves the timeout, it will call getCounter. And basically getCounter will return the current value of the counter that has been incremented twice. So if there is no more requests, both of them are going to return the same value, breaking our invariant. Of course, this couldn't happen at all in Caf.js because of this strong serialization property that we enforce. The second thing that is very different from a system like Express is that we manage the internal state of the actor in a transactional manner. So what that means is that when we do several changes to the state, they are going to be atomically committed to, in our case, to an external ready server for a checkpoint. And also it means that if we throw an exception or return an error, we are going to abort that transaction and leave the state of the actor as if it was. And in Caf.js, we go even farther than that. So what we do is we also provide external consistency. And what external consistency means is that even if you send an external notification, like for example, here using the transactional plugin session, we send a notification to the world with a new state. Even if you do that, we guarantee that if we abort, we will just manage to ensure that that notification never leaves the wire. And the reason for that is because we delay that notification until we have a checkpoint, until we have committed the transaction. So for example, in this case, if you have a function increment, and in this case, we have forgotten to validate the input. So if we pass a string to increment, now the counter gets completely corrupted. We send a notification to the world saying, this is my new corrupted state, unfortunately. But then in getCounter, we do the assertion, we throw at the exception, and the magic happens. The transaction aborts, we roll back the state changes to the cloud assistant, and we ignore the notification. So it's like nothing ever happened. Now, if you were trying to do the same with Express, you will be in deep trouble, because now the counter is corrupted and the world knows that your state is corrupted, and who knows what it's going to do. So what the client library looks like. The client library looks like a WebSocket on steroids, but there's a little bit of magic behind the scenes. So what we are doing here is that when we create a session object, we contact the server and we download some metadata from the server. And that metadata has been extracted from the actual code through introspection. And what this allows us to do is to be able to recreate the external methods in the session object. And that's why suddenly, magically, the increment and the getCounter methods suddenly appear in the session. And there are many more things about the client library to learn, but we don't really have much time today. But I have recorded a couple of talks that goes all the way down on programming cloud assistants. The first one is kind of covering the bases, And the second one is a bit more fun because it talks about how to create interactive applications with cloud assistants and also how to interact with devices. Let me talk about the Caf.js Cloud, and that's the last part of my talk. So when you build an abstraction like I'm trying to do on top of a serverless platform that flexes resources on load, your number one nightmare is that when you try to resell it to other programmers, as I'm going to try to do, if one of these programmers makes a mistake, that mistake can be extremely costly because that is going to trigger flexing resources on load. And as you can see, you can get a $72,000 bill overnight. Now, in this particular case, there was a happy ending because I don't think Google wants to bankrupt their newbie customers, right? But if it's Caf.js Labs, the one that is mediating access, the discussion will have been a bit different, right? In particular, if this keeps on happening many times. So that forces us to change the model. So instead of flexing resources based on load, what we do in the Caf.js Cloud is flex resources based on the number of cloud assistants that are active. And each cloud assistant is going to have a subscription associated with it. And the idea is that we also manage the subscription payments. So the idea is that by doing that, we can take a cut for the infrastructure, then give the rest to the programmer, and then flex the resources. And this may sound a little bit mean, but at the end, it's actually working out great for both parties because from the programmer point of view, they're always going to get a very predictable profit per CA, and there's no infrastructure bills anymore. So in a way, this is kind of similar to an app store, but what we are doing is we are providing also a full backend for your app. But we are also want to be extremely different from the duopoly of app stores that unfortunately we have to suffer these days. And the first thing we do is that we are not a nanny store. So you are going to be able to decide what percentage of the revenue is going to be profit. And the reason we can do that is because the money that we make is not based on the money that you make. The money that we make is a function of the infrastructure cost. So if a programmer increases the prices, it will just increase the margins, right? Obviously, there's some limits because we don't want to be the number one money laundering machine in the world. But even in that case, because we don't care what you do in your app, you could actually have alternative ways to monetize your app. So you could internally run your own in-app purchase schemes, or even forward your customers to your own website to manage your own subscriptions. And in Caf.js Cloud, there's no explicit approvals. But of course, if you start messing with the infrastructure or with other people, we will shut down the service. Now, another thing that is very important for us is to be able to allow people to bootstrap an application with no money. And when I say no money, I also mean with no credit card or no bank account at all. And the way we do that is because when you sign up, we give you a few free units. And these are very few because we don't really have the resources to do anything better. But with these few units, you will be able to deploy your app. And if you have a bunch of friends that sign up for your app, then you could achieve what we call orbit velocity. And with orbit velocity, what happens is that the cost to maintain your app, that is 1 unit per week, something like 10 cents per week, could be paid by the revenue that you are getting from the initial subscriptions of your friends. And that kind of balances things up and makes this app to go forever at that point. And then, of course, the app can grow with the model I just showed you with profit as you go. So you don't need to have any infrastructure bills. And units just simply accumulate in your account. At one point, you might want to transfer these units to other people, and you can do that for real money. And we have provided a reasonably safe mechanism to do so, as long as these transfers are in small quantities over a long period of time. And this reasonably safe mechanism can actually leverage pretty much any peer-to-peer payment system or even cash. So what this means is not that now a kid anywhere in the world with absolutely zero financing and or access to any financial instruments, they can create a very profitable business, a very sustainable business, and that purely based on talent, nothing else. And that goes very far on our goal for Caf.js Cloud, that it doesn't matter who you are or where you live. The only thing it matters is what you can actually do. And we think that by getting rid of the financing side of the equation, we can actually create a platform that achieves most of that goal. So let me summarize what we have described today. So first, we introduce the need of having a domain-specific path in order to lower the cost of the cloud assistants so that they can be pervasive. Then I try to convince you that cloud assistants are not only cheap, but they can also be very useful. Then I show you an example of a cloud assistant and also compare it with Express and show you what is actually different. And then I wrap up with the Caf.js Cloud and a little bit of our philosophy of what we want to do. There is plenty of information in the website and examples in GitHub, and you can sign up for the Caf.js Cloud in that URL, and we would love to hear from you. Thanks for listening.
Cool. Thank you, Antonio. That's very interesting. So we have some questions in the chat.
Thank you.
Yeah, of course. Glad to have you here. I should have mentioned at the beginning, but you're a longtime Speakeasy attendee. So you've been coming to all the talks and attending the happy hours afterwards. So it's nice to have you present what you've been working on.
I mean, it has been great. I mean, especially in those COVID weeks, to have the opportunity to meet smart people through your weekly meeting has been absolutely a great. Thanks for organizing this.
Of course. Yeah, no problem. And so now there's some questions in the chat. If you have a question, you can post it now, and we'll try to get to it as quickly as we can. So I have a question to start with. So I've not heard your usage of this term cloud assistant before in this way. Like, so you presented sort of the platform as a service that you've made, and then you can run these cloud assistants on it using your sort of framework and your platform as a service that you created. My question though is, like, I guess, how is a cloud assistant, the way you're using it, different from like an Express server? What exactly sort of makes it a cloud assistant? Or like, I guess I just don't quite understand exactly what makes something a cloud assistant.
Right. Yeah, so a cloud assistant is more like an actor in the actor model, but it's an actor that can be made autonomous. So think about it more like an autonomous agent that you launch, and it can do things on your behalf. So think about it like a little thread of execution that you launch, and then you just forget about it, and it's running always in the cloud. So it doesn't need any external input to actually do things. So even if nobody talks to it, it still keeps on doing things like polling other services or interacting with other things. So that kind of changed the model from a purely request response model that you will have in a traditional Express system to something that can combine request response with, I do stuff, and if I found something interesting, I send you an event, that kind of thing.
I see. So it's really a specific term that means something in this actor model. It's sort of like an agent that can take actions
Yeah,
and can respond to requests, but it can also initiate actions. And it means something specific in this model.
yeah, and it's I think about it more of a kind of a base implementation class that when it gets decorated with different plugins, it can a little bit change these behaviors. So for example, when you can customize your core cloud assistant to become a reverse service worker, or you can customize your cloud assistant to, for example, create an, a continuous GraphQL query based on data from external services, or you can customize it to, and that's kind of the idea. So you have kind of a baseline, and then you iterate on it.
Mhm. Yeah, in particular, the stuff you talked about having built into it, such as being able to take like a Bluetooth device that's on your local network and then make it exposed, is really interesting. The reverse service worker idea. I never, I mean, it makes sense that you can do that, but I never heard of anyone doing that before. That's pretty interesting. And just
Mhm.
the phrase reverse service worker sounds pretty cool too. Just sounds like some mad science.
Yeah.
Um, let's take a question from the chat. So someone's asking, so why Caf.js instead of something like a small instance running an actor system, using Erlang, for example. I see the cost improvement, but it's an order of magnitude for getting things like much more RAM and requests. Can you compare and contrast this to a persistent running actor system?
Yeah. So one of our goals was to ensure that you could have three programs, one running in the browser, the other one in the cloud, and the other for the bridging device code, and treat these three programs as a single unit, and deploy them and debug them together. And the fact that we have JavaScript in these three components helps you tremendously, because now you can just use standard Chrome tools for setting breakpoints and move around. So initially, the first prototype of Caf.js was actually done with Erlang. And then we realized that if we wanted to do something that would be easier to integrate with the browser and also with the device, having a JavaScript as a common language would be very useful. And and yeah, if you were to implement this with Erlang, the backend, Erlang is going to always be more efficient, and it also it's easier to handle multiple cores. But as I said, the trade-off is that it's a bit more difficult when especially you want to expose this to people that only have front-end experience. That it was
Hmm.
kind of our initial goal to make it so that someone that only has front-end experience now can create a cloud backend and also bridging code for a device and debug everything in the laptop using three Chrome debugger instances, and see in their laptop how a request goes from the browser to the simulated cloud to the simulated device and back. And that is the kind of thing that it's hard to do with something like Erlang.
Hmm. Yeah, you just can't beat the accessibility of JavaScript. I mean, the number of people that know
No.
it, and the fact that everybody pretty much has the programming environment and the debugger tools already installed on their computer because their computer comes with a browser, or they already have Chrome or whatever. It's hard to beat. So
It's hard to.
that makes sense. And the ecosystem of packages that you can plug into for something like this also seems advantageous. Cool. Yeah. So let's take another question. Someone's asking, this is probably a quick one. How does the reaction time of your system compare to something like a Google Cloud? I know depending on what exact services you use on the different clouds, if you're doing like serverless functions, sometimes those things can take forever to boot up. Assuming it's assuming it's running already too, sometimes you don't have the best response times? What do
Right.
you think about this?
Yeah. So basically, our goal is, there is no a startup time because these processes are running all the time.
Mm-hmm.
So and therefore you don't have the startup time that you will have with a Lambda if you don't pre-provision uh, the the Lambdas. But the other thing is that when we do a checkpoint, we do it in Redis. And our goal is to be within 10, 20 milliseconds for the whole request processing and checkpoint to come back. And,
Mm-hmm.
if you think about 20 milliseconds for a request, well, the time it takes you to get there is probably much more than to actually do the backend. So we want to make sure that you can actually use this for interactive applications that are, and also once that you have the notion of autonomous and the idea of having something that you customize that is running in the backend, you can eliminate many chatty protocols. So instead of having to go back and forth many times, you create a method that is going to do on your behalf a sequence of internal actions. So that kind of helps you to eliminate perceived latency.
Mm-hmm. Makes sense. Um, cool. I'm going to ask one of my questions. So I wonder, like, this sounds like a big project, right? There's lots of parts to it to make it all come together, and you have to, you're writing these plugins to handle, these individual devices, and you're writing this framework, you're writing this domain specific language, and it sounds like a very ambitious project. What's sort of your approach for shipping something that is uh, like, I guess, yeah, what's the sort of first goal of something you want people to do with this that is maybe like the first step to something useful without having like the whole thing needing to be built out
Right.
for it to be useful? Like, what's the first use case, I guess, that you have in
Yeah.
mind?
Yeah. So there is a getting started guide in the documentation, and the idea is the first thing that you can do is just create a cloud assistant that doesn't need to have a user interface, or it doesn't have to have a device or anything. You just can write your app, launch it, and then now you can have something there that is forever, right? And you can just interact with it with a simple script, right? And that thing can do things like, for example, query a service periodically, or do any kind of task like that. And so and that with that you could do very quickly. I mean, I install the tools and can get that running, could be an afternoon. Then the next step is to provide a React user interface to it. Yes, and you will see that that is reasonably simple to do. And the next step could be to add the device side. So now when that receives an event from somewhere, now you can switch off the light at home, right? And to do that, you will do either you use your phone for a web Bluetooth connection, or I tend to use a Raspberry Pi that also can run the same code. And then the last step that is a little bit more fancy is if you are into WebXR, now you can create an avatar for that device, and you can hook up the avatar to that cloud assistant, and now you can interact from VR and AR. And one of the key things is that you can maintain all these user interfaces in sync with the cloud assistant, so that any changes, for example, in VR, they get reflected in AR, and changes in AR get reflected in VR. And that is kind of cool because it helps you to interact with devices in new ways. But that's kind of I'm assuming, the natural progression.
Mm-hmm. So how long did you say that demo would take to show us?
Yeah, well, depends on the demo gods, right? But yeah, So
I'm trying to decide if we
hopefully,
have time for it before we have to go
yeah.
to the social
I
part.
mean, I think it will be about 5 minutes. I think so. But if the demo is already in YouTube, is this of the talk, and I will post the links in my Twitter account. But the demo is just basically that I have literally wire myself to a ECG machine that is Bluetooth enabled, and basically with that I want to export that basically that interface to using a device, a Bluetooth device called a Healthy Pi. I can show you my heart
Go
basically
for
through
it.
a web app. Well, that we try? Yeah.
Let's try it. Yeah.
So I'm changing cameras here, and of course the demo goes. Yeah. Okay. So what I do here is just pair with this device. And this is a Bluetooth device, and this is just Chrome. And what I'm going to do here is just connect myself up. And hopefully you are seeing now my heart. It's a bit noisy, but because there's so much electronic equipment here. But what I can do is I can create a URL for this device, and there's no hub, there's nothing here except the phone and this Bluetooth device. And I can email that to my account. And hopefully I get here an email with this URL that has this encrypted token. And when someone, in this case the doctor, clicks on this encrypted token, they can see my heart in real time, as you can see. And now what I can do also is I can mail that to Feroz. Is it okay if I send a message to you and disclose your
Sure.
is that okay?
Yeah, it's fine. It's no problem.
And Feroz, if you could post that link in the chat. And I'm not sure whether it will limit the number of characters. If not, what I can do is try to create a tiny URL. But the idea is that anybody now that has this link that has this authenticated token, now when it clicks on that link, they have, I think, 24 hours to see my heart as long as it's connected. And that is kind of the idea, that you don't need to have any previous relationship with the receiver. So let's say that you have that I'm basically talking with a doctor. I can just wire myself up, have my phone, connect to the device, send the doctor an email, and when the doctor clicks, it can see my heart in real time. And do that with pretty much any Bluetooth device that is around you. That's kind of the things I want to do.
Wow, that's really cool. I think you should have started with this demo. I think you undersold it a little bit. It's actually super
Yeah.
cool seeing the heart rate go right now, and especially reacting to what
Is
we're talking about
is
right
it
now.
is it working or not?
Yeah, it's working great. Yeah, I
So
see it on my screen.
so now I cannot say any lies anymore, right? You are going to detect everything.
Exactly. Yeah, no, I mean, I could share my screen here. Like, I mean,
Yeah,
it's
yeah.
working for those who didn't visit it themselves. I have it up here on the stream now. Yeah, it's so cool.
Yeah, and and the key for to make that work is this reverse service worker that I described, implemented with a cloud assistant. That is the one that is always there and is doing the authentication, and then it's relaying all the way to my phone.
Hmm.
So that's why you need the cloud assistant to actually do
Uh-huh.
that.
Right.
And please, if there is a doctor in the audience and they see anything bad with my heart, please send me a quiet email, gentle, okay?
Yeah. I can't tell what's noisy and what's what's real though. But and I'm not a doctor, so but this is really cool. Thanks for doing this demo. Next time if you ever give this talk again, you should start with this demo
Okay.
and send the link to everyone so they can see your heart, and and then keep it on their devices throughout your talk so they can see how nervous you are. I think that would actually work really well. Super cool. Okay, well,
Okay, great tip. Thanks.
I'm glad we spent the time to see to see the demo. So now I think we should wrap up. So thanks so much for coming and speaking at Speakeasy.js. Glad to
Thank
have you,
you.
and thanks for sharing all that with us. And I think people can search Caf.js if they want to learn more.